All right. Well, hi, everybody. I'm Kevin Czajkowski, Dr. C. And what we got to do is mute your line, please. And then, Janet, please mute people's lines. Okay, we have maybe Kate Cooley isn't muted yet. Okay, that might have taken care of. All right, good. Because when you're not talking, please mute your line, because then otherwise it interferes with everything. But hi, everybody. I wanted to welcome you to the first Globe Mission Earth webinar for the year, and we're going to focus on the urban heat island effect this year. And I'm really excited. You know, we've had the urban heat island effect campaign for Globe for a number of years. This year we're focusing on having webinars associated with it. We're going to have it in October, December, and March. And get as many people around the world taking surface temperature measurements as possible, and having kids do projects on urban heat island effect. And that's something really I want to emphasize this year, is to have students do projects and then present those projects at the various Globe conferences or the International Virtual Science Symposium through Globe, so that anyway, we can have the kids doing projects, students doing projects. Anyway, I want to welcome everyone. Janet Struble, she handles a lot of things, and many of you know her. And then Sarah Merzwiak, she's going to help with some videos today that the students at Jackman Elementary did, and the teacher, Kelly Reeves. So let me share my screen, do some urban heat island stuff here. Let's see. See if I do this correctly. All right, does everybody see PowerPoint? Everybody's probably muted. Oh, thank you. That's all we need, one person to say yep. All right. So here we go. We're going to focus on urban heat island effect. And as I mentioned, this is part of Globe Mission Earth. I even got my cool shirt on. We got these from Land's End.
That way it's cheaper near here.
So Janet, try to mute people. What? So if you're not,
it is very good.
Please mute yourself if you're not talking, or if you don't want to talk to me. All right, so Globe Mission Earth is a partnership between the University of Toledo, Boston University, UC Berkeley and West Ed in California, Tennessee State, and NASA Langley, and we have other partners too. We have Palmyra Cove Nature Center in New Jersey. We have the state of New Mexico. Boy, there's lots of people involved. And there's our goals there. We're funded by NASA, and we're working with teachers and students to have them do Globe projects, actually. I should change that. And use NASA resources, giving teachers professional development, and then also working with the public. So here's our urban heat island effect campaign kicking off. There's some students from India and Farid from Israel. Okay, there we go. So what is the urban heat island effect? Well, the urban heat island effect is the fact that surfaces don't heat up the same way in the sunshine or even at night. They don't cool off the same way because of the way they're made or their color. What we want students to do is to take observations of asphalt and grass so they can compare them themselves, but also then share that on the Globe website so students can compare between schools, rural schools and urban schools. So this picture, these are thermal images of a city landscape. You see the trees are blue, that's cooler, and the buildings are red or white, which is hotter. And here's one down here on the lower left. The grass is cool, the kind of purple color, while the house is warmer. So there's been studies looking at urban heat island effect in the United States, and this is a map of what might be contributed in the United States. And you see the legend at the bottom, that's in degrees Celsius, I believe. Yep. And red is about 2.5 degrees Celsius. See all the places where it's warmer than it may have been if we didn't have the cities. What's interesting is the places down south, like Florida, Texas, Arizona, they don't have as large of an urban heat island effect as we do up north and in California. Now I wanted to show this. This is NASA Earth Observatory. So they had a story about urban heat island effect. One of the reasons I like this one, this is the city of Buffalo, and it's at the end of Lake Erie, and here's Grand Island and the Niagara River going around it. I grew up right there on the Niagara River, and so after school every day I'd go fishing. I'd get my fishing pole and 5 worms and run across. Okay, I had to go past the factory, over the railroad tracks, over a 4-lane highway to the park. Maybe not the smartest thing in the world to do, but I had a lot of fun doing that. So this area does have urban heat island effect. Even Buffalo does. And this map shows kind of the worldwide estimation of what the urban heat island effect might look like. Now, in the United States, we haven't heard about it too much. One of the reasons we have a lot of air conditioning. Now, this fall, it was an issue in Michigan and parts of Ohio when school started up. We had a heat wave going on, and some of the schools canceled or got out early, and because they didn't have air conditioning, and of course it's too hot in the classrooms. One of the teachers told me that their classroom was 103 degrees in the afternoon. They did have school at that school, but in other parts of the world, urban heat island effect is becoming a big issue. And I went to a conference about urban heat island effect, and it turned out I was the only person from the United States in the whole room with the talks. Other people were mainly from Southeast Asia, India, China, Indonesia, because the people are very, mute yourself, please. Or Janet, please mute people if you can. Anyway, Southeast Asia is very worried about the urban heat island effect because it's already hot there, and then the urban area is adding to that heat. All right, and you may have heard that this summer there were heat waves around the world. Globe had its annual meeting in Ireland, and then of course the UK had a heat wave. The reason I show this image here, the UK is usually green in the summer, and you see it's brown, and so is France. It was actually very, very dry. So when we went to Ireland for the Globe annual meeting, it was really hot, and so hot. I mean, there's no air conditioning really in most places. Hotels don't have air conditioning. But also Norway had a heat wave this summer. Greece did, and they had the fires. Japan had a heat wave, and a number of people died in Japan. Actually, in the UK, they estimate over 650 people died from the heat wave itself. In the United States and Canada, of course, have had heat waves this summer. So a lot of heat waves this summer. And then when we have the urban heat island effect on top of it, that makes it more difficult for people to to cool down. I just have a little picture here of my son Timmy in Ireland, and he's standing in the shade, of course, staying cool. So why do we care? I mean, one thing is people die, it's a health issue. Another is that energy use increases dramatically once you hit 80 degrees Fahrenheit, 27 degrees Celsius. The energy goes up dramatically from air conditioning. So mute your line, please. Janet, you have a full-time job today, muting people. So anyway, that's good. We have lots of people on the line, so that's good. I wanted to show you some research that was conducted at the University of Toledo. My neighbor in the office here, Yangqing Xu, she's a new professor, about 3 years now she's been here. And she had done some work in China on the Yangtze River Delta. And they looked at urban heat island and how it relates to ozone, so smog. And what they found was that urban areas that are hot because of urban heat island, that's the kind of on the coastline here, they have more smog. They also have more NO2. It's another pollutant that leads to smog. So it's really interesting. So of course, ozone affects people's lungs, and it's a health issue. So why do we do it? So surface temperature is at the heart of the energy budget. In this diagram here, you can see that the sun is the source of energy for the surface of the earth. So the sun heats the surface. And the energy goes into different things. So we learned today in class, one of the students said, well, grass is moist or can be moist, and you have evaporation from the grass, and that takes up some of the energy. So evapotranspiration, that's evaporation from water bodies and transpiration from plants. So you get evapotranspiration, and that takes up some of the energy. By the way, I talked to my wife, well, our first date, I used the word evapotranspiration, it's a big word, and she still married me. So anyway, that's a good thing, a little side note. Here we have this sensible heat flux, that's the heat itself. So the ground heats up, it heats the air above it, and that air is sensible heat flux. And then we have energy that's emitted to space. The Earth is in balance, or more or less in balance, with the energy coming from the sun, and then it emits energy to space in the long wave wavelengths. And of course, the infrared thermometers, they measure the long wave radiation. So that's the type of energy that the infrared thermometers are observing. And then some energy goes into the ground. But anyway, this surface temperature is at the heart of this energy budget. So that's why we take the observations. So here's a demonstration. My students went outside today and took surface temperature observations. It was a lot of fun. And you put your arm out, kind of straight, I guess, and hold it at arm's length. Point the instrument at the ground, press the button, let go, and then lift up and read the value to the tenths value, right? So you want to make sure you have the tenths in there, and in Celsius. So this is Matt Fenzel. He's a Globe alumni and helping a student from India take observations. So these are the schools around the world that have taken surface temperature observations. Quite a number, and the number keeps growing every year. I noticed in particular Taiwan, on the island there, there's a number of schools taking observations, so they're part of this urban heat island effect study, so it's really great. Okay. Okay, so here's some observations from last year. In December 7th, and you can see the temperature. Blue is kind of cool. The Middle East was hot. Trinidad and Tobago, of course, that was very hot. Taiwan was very hot. I kind of see the temperature variations. Alaska was cool. And if you have schools near each other, one in a rural area, one in an urban area, then the students can do that comparison. It's a little harder if the schools are not near each other, so it's important to kind of do that. And as I mentioned, we want students to do presentations. And these aren't all urban heat island presentations, by the way. These are presentations. But actually, not a lot of students have done urban heat island presentations, projects, and presented them at the Globe annual meeting. The Salites conference at the University of Toledo is going to be May 1st, and that's going to be during the day between 10 and 1 o'clock. I don't know, let's see, I think the International Virtual Science Fair will be March 1st deadline. And the symposia, the regional symposia, those locations have come out. I'm not sure about all the dates. We'll update those through our webinars over this year. And the Midwest one is going to be in Iowa, actually, in Cedar Rapids, I believe, at Northern Iowa University. So that'd be cool to get to go there. I want to show a little data. This is Jeff Bauman's school. Now they kind of, looked at different land covers. They're a rural school, even though they're close to an urban area. And you can see they did parking lots, and the parking lots were warmer than a grassy area. And they had a pond they took observations in, and that was even cooler than the grass. So, all right. And then you see the data here. They took observations over time through October last year, and pretty much the sidewalk was warmer than the pond the whole fall. It was interesting. All right, I wonder if right now I should now switch gears a little bit and have Sarah show the video. And Sarah, hopefully that'll work. All right.
Sure, yeah, let me share my screen. Okay.
So this is Jackman Elementary in Michigan, Bedford, Michigan.
I gotta shrink my Zoom window. Okay. All right, hopefully it's loud enough for you guys too.
Yeah, maybe turn the volume up.
Okay.
Hi, my name is Kelly Reeves. I work as a fourth grade teacher at Jackman Elementary in Bedford, Michigan. This is my 22nd year of teaching, and I absolutely love science. That's one of my things. I know you didn't how to prepare for that.
Wait, are you going to do partners or would you like to do
One of yourself.
partners?
Yeah, because it's easier to write, right? Do you need a couple more, This year, teaching it again because the kids absolutely loved doing it. I started it earlier this year, and with the nicer weather, we've been able to be outside a little bit more. But honestly, even in the wintertime, they really enjoyed going out and doing observations. I did a little more in depth on what the satellites look like this year. We kind of just hit the clouds last year. So this year, we talked more about what the satellites do and how they orbit around the Earth. And so a little bit more in depth this year because I felt more comfortable. So the more you teach something, the better you get.
What kind of projects for Globe have you done? Or research?
We did researches where we did IRTs and we had to check out how much degrees Celsius it was, and then we posted it on Globe.
Okay. Somebody else want to add to that?
We looked at the clouds to see, and we looked at the temperature of the ground in Celsius.
Yeah. Okay. Go ahead.
We read different types of surfaces, like we did blacktop, regular white cement, and then grass.
Oh, okay. What kinds of things did you find out? Somebody else. Yeah.
We found out that the darker colors absorbed more heat and the lighter colors reflected more.
Nice. Okay.
We found out that grass isn't as hot as blacktop because it is more moist than blacktop.
Awesome. Yeah. Okay.
The clouds are like a different shape and kind of a different color when it's snowing instead of when it's just clear.
Ah. Do you guys pay more attention to clouds now?
Mm-hmm.
Yeah, especially on a day like this when there was a storm coming. Yeah.
Even that I've just done this 1 year, they are so excited about it. And they were wonderful. Like we looked when you guys gave us the results, like, hey, you're like 3 in the world. And then we got to be number one. We got to be number one. For them to see where those other schools were. That was a great, a geography lesson. And they really felt that they were part of that they were making a difference. And by them putting their own information in and how it had to be accurate, and like, hey, you're talking to NASA scientists here, make sure you're doing it all. It just gave them a sense of empowerment, which is great. And that's why they're excited about it.
That's awesome. So you pulled up a map of the other schools that were close.
Yeah, they were beating us, and then we beat them, and then, So it is 75 kids. And I think that's maybe one of the reasons why we were so much higher is because we had so many entries, because I have that many kids that were inputting in the entries and stuff. So I'd pair them up, 12 IRTs. So I paired them up together.
Okay.
So usually a student who was a little more great on the accuracy and being on task than one that, needed that extra help. Yeah. So put those two together, and that was their Glow partner. So then we would go outside with our clipboards, do it on paper, and then come back in and put it in on our Chromebooks because we're a one-to-one school. We're talking about how the GPS impacts everything, tracking animals, weather, rain, and how many different jobs. I mean, that's just a great avenue to talk about careers too. Like, yeah, you think that scientists are in a lab doing and mixing chemicals, but that's not just what scientists do. So I think that has opened up a lot to them to see, and that they're doing it right now. Like, if I can do it now, I go to school for this, I can still do this. Like, this is something that I really can do. I said, there are people who are really doing this. They're tracking weather, they're tracking surface temperatures. That's their job. They get paid to do that. Is that something you want to do? Like, yeah, this would be so cool.
Yeah.
Like, it changes what you see in a cloud. Like, before we did Globe, like when you look at a cloud, you just see different shapes. But now that we look at clouds, they look like certain types of clouds.
Mm-hmm. And so you guys had a meteorologist visit your classroom, right?
Mm-hmm. Yeah.
Did he actually come to the class?
He talked to all of them in our cafeteria. So we got all fourth grade, 100 kids.
Wow. What did you guys think about that? Yeah.
It was so exciting because we had some experience done with him.
Okay.
I thought it was cool because we could hear about like an actual professional person who looks at clouds and can tell like when there's going to be rain or snow or when it's just going to be a nice day out. Tell us about it.
Mm-hmm. Yeah.
We learn more about the tools we use for measuring the winds.
Oh, okay. Was it neat to see someone who actually does that for a living?
Yeah.
Yeah. Does anybody want to be a meteorologist? Maybe? Yeah. Nice.
I think it was cool that satellites actually checked our work. Like when we put in our data, the satellites checked if it was the same as what we put in our computers.
Yeah. You would never think that what you do here on your school grounds could actually have something to do with a satellite in the sky, huh? But it does.
And on the back, we have 0 trace of snow, and then it's our surface temperature, or site overall surface condition is dry, and windy, very windy, and then this sketch of this not that good.
Let's see.
Can I get it in there?
It probably is safe. I think everyone's safe.
I think I got it.
It's gonna have to.
Good job.
As you can see, we have our predictions for the year and the temperatures. The first one we did, the wood chips were a lot hotter. The second one we did, the grass was hotter. And then the third one, the wood chips were hotter again. So the data, you can tell the wood chips were hot. We took temperatures in Celsius. We got almost all 24 degrees for the black top. The wood chips, we got lower temperatures. The reason the black top is hotter is because it absorbs more heat. We learned that the wood chips are much hotter because black top is mostly 24.6 and the wood chips are 25.7. Our hypothesis is that the blacktop will be hotter than the wood chips. Our references are globe.gov and Google Maps.
Nice job, Gabby.
Yeah. Give her a hand.
I would like to take more observations and delve a little bit more into what they use that data for. Because we looked at it briefly when I first introduced it, but then really didn't look more into look at what you can see from these satellites and what they're sending us and what are they really doing with it. So we talked about it briefly, but not like in depth and looking at reports and data. So that would be better.
Hey, when you guys are talking though, too, Sarah, I just want to make sure, like, for new teachers that want to try it, like, it's so easy to do with partners, and that you can tackle it. Because right now it looks like we only have a couple here, but I really have done it with 25 to 26 kids. So it is definitely attainable. I thought that would be my biggest problem, but it really worked out. So if you're afraid to try it anyway, because it was fun, you guys, wasn't it?
Yeah, I love having.
Okay. Oop. I want to replay. Let me. Go
Well,
back.
thanks, Sarah.
Sure. I gotta stop share. Okay. There you go.
All right, so let's see. It should switch to me, right? Okay, hopefully people can see me. But anyway, that was really great from Kelly and her students. Sarah and I went there Friday, and they're fifth graders now. So those were the kids that did projects last year as fourth graders. One thing that was interesting, well, no, I don't know. So, yeah, okay. Anyway, so what I want you to do is if you can write questions in the chat box, like if you know, Kelly's presentation, her talking about how she does the surface temperature observations with her kids, how she does globe with her kids, If you have questions about how she did it, or want to make a statement about how you do it, please put that in the chat box so that we can discuss it here at the end of our webinar. They were #1 in the world for at least 2 months in taking surface temperature observations, and it motivated her kids. They just kept wanting to do it. And I don't, that wasn't a plan of Kelly's. It just kind of happened. And then, the projects they did were very good. And you notice that the student was presenting, she said, the wood chips were hot on one day, but then the grass was hotter on another day. And then the wood chips were hotter the third day. It's interesting, analyzing the data. All right, so I'm going to continue on with what I was talking about. So here we are. So getting back to the project idea, when you work with your students on projects, have an idea of what you think you want the students to do. Just don't have them do anything, but kind of guide them, but then have them choose within your framework, right? So one of the things that young kids like to do is take the temperature of the playground. And I show Maria here from the Dominican Republic because I thought she did really a cool job with her students. This is on the Globe website, by the way, talking about the green wall and the green surface of their playground. She told me that their school had put a blacktop asphalt playground in, and of course Dominican Republic is very hot, and so the playground just became really hot for the kids to go out on. So what they did was they tested different paint colors using the infrared thermometer to see what color would make it coolest, and it turned out green would do that. Now if you go, this was published on the Globe website about 5 or more years ago, let's see, but they did this 13 years ago. That's back a long time ago. But anyway, UC Berkeley graduate students have now done this type of project and publishing the research. Of course, here the kids did it first, so that's pretty cool. So I wanted to show some of the resources we're doing. This is my reminder page for the Urban Heat Island campaign. Of course, we have the Globe website. Oh, Jesus, things keeps getting in my way. Let's see. All right, so I wrote a blog. So I'm going to be blogging on the Globe website. And if you go to community, there's blogs there and community blogs, and also the professionals, STEM professionals blog. My blog will show up. So I'll just click on that. Oh yeah, I need more than 106 views. I need lots of views. So if you guys go and view that, it'd be great. Talk about the UK a little bit. This webinar. Reason I wanted to show this, I went to Chicago this summer and worked with employees of IBM from around the world. They're international employees. They came to Chicago for environmental workshop or type of thing in the summer, and they went out and took surface temperature around Chicago of different surface covers, and they also did it of places shadowed by the building. So I thought that was very interesting, and looked at that. Now going back, there's some students from Akron who had done projects on the urban heat island effect. So I wanted to emphasize, yeah, please have your students do projects on the urban heat island effect. And then you can make comments, and I will comment back to you. So you can put comments at the bottom. Now the Facebook page, I didn't get to open, but we do have a Facebook page that you could like. So this is as far as I got. Like this Urban Heat On campaign on the Facebook page. Okay. So going back to this. And then what we're going to do is have a number of webinars throughout the year. And please join us for the next webinars. Here we have November 14th. David Padgett from Tennessee State, he's a scientist in geography, and he's going to talk about his work. And then Jeff is going to talk about his school, and that's the school I showed today. Then in February, Nectaria, she's actually from Athens, Greece. She's going to talk about her work with the urban heat island effect. and Landsat, the satellite. And then Diana Johns from Crestwood High School in Dearborn, she'll talk about what she does. And then lastly, in April, we're gonna look at what's, the data and that type of thing and what students have done. Okay, so anyway, that's what I wanted to share with you today, kicking off the urban heat island effect. We could look at some of these comments. Let's see. Oh, okay, so Kathleen asks, how can we find the Facebook page? That's a good question. I don't know, Janet, do you know the answer to that? It is probably Globe Urban Heat Island Effect campaign, something like that.
Urban Heat Island Effect.
Okay.
If you just search that on Facebook, it should come up.
So you don't need the word globe in front of it?
No.
Okay, great. Let's see. John asks, is surface temperature going to be added to the Globe Observer app? I'll say yes, that's the goal. Will it be done soon? No. So there's other priorities of Globe, getting other things on the app. And so they're actually going to come out with a number of observations that you can do with the app, in addition, of course, to the clouds and the mosquito habitat, as well as the land cover. So they're going to, I think it's going to be air temperature, probably relative humidity, maybe precipitation, and surface temperature will be down the line, but I'm going to guess at least a year away. So yeah, I'm sorry about that not being, high on the list, of going to be done soon. All right, so thanks, Tracy, for posting the Facebook page. Good, good. Yeah, Kelly is an inspiring teacher. Like I said, I was thinking, I don't know that she intended to do so much with Globe at the beginning of the year, but the kids really liked it, and they just kept doing it, doing more and more. And she has a great attitude. And fourth graders, right? They can enter the data on the Globe website. So you don't feel as a teacher that you have to do it yourself. Have the kids do it. So are there questions about implementing in the classroom, or what we should be doing? October is our Urban Heat On campaign. Okay, and so so actually Tracy sent me a text, but I don't know exactly what her question is. Okay, so Peter's saying surface temperature observation require 9 measurements. Yep, but they would need to be on one, thank you, Peter, one homogeneous surface. So if you're going to be taking observations of a grassy surface, you need to have 9 observations from that grassy surface. Now you can take as little as 1, but we want you to take 9 because that gives you a good average. And then you distinguish the different surfaces by creating a site for each site. So, okay, this is a good question. I was thinking I should probably do that. Then I have to remember my login. Let's see. So let me share. Let's see, I always forget to share screen. So share the screen. Okay, so here we are, Globe website. Let me see if I can log in. Now, I had the student log in this morning. Let's see. Try that. I think I have to look up my logins. Wait, pardon me, what do they call that? Ignore the guy behind the curtain. Let's see, let's go with this one. Should I go with the student one?
The Toledo.student1@Globe.
That's the one. I know, all my students know it now. Yeah, that's better to use than my globe.gov. And then it's, okay. In theory, it will sign in. Okay, see, I have trouble too. So everybody, I'll see it. It's hard sometimes to remember it. So enter data, there's a little button here. Another way you can get enter data is through the data, Globe data, data entry, and that's desktop forms. Okay, don't do training because the training won't show up anywhere. So enter data. Okay, organization should show up. Now it was a little slow today. I don't know if it's the internet in my building, which it might be. See how it's not bringing up the stuff. Taking its time. Okay, now see, I have an organization, University of Toledo, and I have lots of different sites. But what I can do, you can do also, if you click on, you define a site, I'll show you that in a second, but if you click on the plus sign, you can choose by choosing the star, like freshwater, it'll pop up on top, so that way your students can see it very easily. So if you add a site, it's over here on the right, add site. So each time you have a different cover type, you need to add a different site. Now when we put it on the app, it'll be a lot easier because your phone will have latitude and longitude, and you probably will just do pictures. So you click on surface temperature, put in some comments. If the size is less than 30 by 30 meters, put in the actual measured size. Maybe it's 10 by 12 meters. What's the cover type? I'm just making this up, short grass. IRT, let's see, maybe I have a fluke one. Create a site, so I won't click create site. Oh, I have to have the latitude and longitude. Oops. Yeah, so you have to have the latitude and longitude. It could be from a GPS. You could do it from like Google Earth. And Sarah has little videos on the Globe Mission Earth website that help you through setting up your site using Google Earth. And so anyway, you can email us and we will email you back and where it is if that's something that will be helpful for you. Okay. Here's a question John asked. Can the optional temperature, relative humidity, and barometric pressure in the bottom of the clouds data sheet be pulled from the Kestrel, which is, the Kestrel is from the kites. There's a kite protocol that David Bidlowski and Andy Henry and those guys came up with, so you can put an instrument package on the kite string and take it up with height. You know, John, I don't know the answer to that, and I don't want to give you the bad answer. Of course, I always break the rules, so we're, try it and then see what happens. Worst it can do is someone say, well, maybe you shouldn't do that. You could send a message to help@globe.gov to ask that question. And then Tracy says she thinks she can. That would work, especially if, it's at, eye level. That's basically where your observations should be. Okay, so you've been doing it already. Good. There you go. All right, other questions? So also Peter asked, should we take observations on different surfaces for our own benefit? And the question is, or answer is yes. So if your students, have them come up with a research question, and the Kelly students, they wanted to know the temperature of the wood chips on the playground. So that was one of their observation points, one of their sites, but and they included it on the Globe website. So always put the data on the Globe website. There's a number of schools that have wood chips in their playgrounds, and they've put their data on Globe, and it would be interesting to compare those schools, right? So it may not be used by you if but it might be, and it might be used by someone else. And the question from Tracy is, can you enter surface temperature measurements from any time of day or for multiple times a day? And the answer is yes. Now, there are some things on the Globe website talking about solar noon. I actually didn't write that. Someone else did. So I'm the Globe scientist that does surface temperature, urban heat island effect, and I welcome surface temperature measurements from any time of day. And especially taking multiple observations during a day is really interesting as things change over time. Okay, so I hear yay. All right, so I'm just answering questions right now. One thing I wanted to welcome my students for my weather and climate class. Thanks, guys, for calling in. Many of them are education majors and will become teachers someday. And Peter at Boston University, he had some of his students also call in. So it's kind of neat. University of Toledo students, say hi to the Boston University students, that type of thing. All right. Yeah, thanks, John. Yeah, taking any time of day opens up surface temperature, opens up the things you can do. All right. Don't know everybody on, but if we don't have any more questions, we can wrap up for tonight. I should mention, I don't know if Peter, if you told your students that we're having kind of like a university student competition of who could enter the most data on the Globe website. And
you'll be getting a lot from us.
Okay.
You're on.
Great. So Tracy asked a question, are there any 5 days in October, or certain days in October we want observations from? It'd be great to do every day and all day long, but that's not realistic, right? So we're hoping that schools can do 5 days during October, and it could be any days. Now, one of the things, if you wanted to partner urban rural school, get some partnerships going, that's something that we might be able to facilitate. So let us know, email us or message us somehow. And because the best when you do an urban rural comparison is to have observations on the same day about the same time, right? That makes sense for the projects. All right, thanks, Kathleen. Okay. All right, well, we can let people go. Oh yeah, and the revised data sheet is on the Globe website. Thank you, Sarah, for getting that going. It has the current cloud sheet attached to it. So anyway, thanks everybody for calling in. Oh yeah, and I should share our, oh yeah, see, I have to go back to sharing. Hang on a second. What am I doing? All right, I have to roll the credits, right? Here we go. So if you want to contact us, there's some of the things. You have my email address, Janet's email address, our website, Facebook page for Globe Mission Earth. The Urban Heat Island's not on this page. Sorry, I didn't put it on there. We have our YouTube channel. All right. And you guys, everybody have a good night.